Alright, so this video we'll be looking at quite an interesting integral, one that I haven't seen very often come up in any course in HSC, but especially in the 4-unit course. So this is the very last question in the 2014 HSC exam, and it asks you to integrate log x over 1 plus log x quantity squared. So when I originally looked at this question, I thought maybe we're going to be needing to use some sort of substitution. And the first thing that came to mind was to let u equal lnx. So if we went ahead and said let u equal lnx, that would give us here, we'd be getting something like u plus 1 over u all squared. And then I thought, well, maybe we can use some partial fraction decomposition there. But really, when you look into it, we need to differentiate both sides. And when we do that, this is what we get. So we need to make dx the subject. We're going to get x times du, and that's going to be e to the power u. So instead of getting u over 1 plus u squared, we get u times e to the u over 1 plus u squared. And to integrate this, we're probably going to have to use some sort of integration by parts, or maybe some other technique. But that's going to be quite complicated. So I thought there must be some other way that's better than using this method. That's to say, even if we can use this method at all, we're not too sure. So I thought, well, what are some other tricks that are commonly used to simplify integrals that look pretty nasty, to simplify them into something that's, quite doable. And the real trick is to think of this whole function here as being multiplied by 1. Now you should have come across this when you were integrating some functions like, I'm not sure, maybe log x. If you wanted to integrate log x, you would imagine that as 1 times log x, and then you'd use integration by parts there. Same thing with the inverse functions, like inverse sine, inverse cos, inverse tan. So, how can we incorporate multiplying by 1 into this function? Now the real trick, and I haven't seen this very often, but it's to write the integral as x times log x over x times 1 plus log x squared. So, we've multiplied the numerator and the denominator by x, which does nothing to the function of the value, but there is the question of changing the domain of the function. So we now have this x in the denominator, so clearly x can't be 0. Now we should be a little bit worried by changing the domain of a function, especially if we're integrating, because we know that an integral is all about area. But here it's not a problem because x already can't be equal to 0. So now that we have the issue of the domain out of the way, we could go ahead and simplify this and see where we can go. Now, how can we consider this to simplify it to give us something that's easy to integrate? And again, this is not an easy thing to see straight away. It would take some practice, particularly some sort of familiarity with x log x. And we're going to use integration by parts. We're going to choose u to be x log x. And the reason we're going to do that is because if we differentiate x log x, that actually gives us 1 plus log x. And that's going to be helpful. So let's do that. Differentiate it. We're going to get x times 1 on x plus 1 times log x. And that will simplify to 1, and that's log x. So, like I said, we get 1 plus log x. Now, that means we need to choose v dash as 1 over x into 1 plus lnx squared. Now, this itself looks pretty difficult to integrate, but really, if you look close, this is just 1 over x times 1 plus lnx to the power minus 2. Now, what you can hopefully see is that here we have some function raised to some power, and we have the derivative out the front. So we can apply the reverse chain rule straight away. That's going to be 1 plus log x, that's our function, raise the power by 1, so minus 1, and divide by that new power. So it's divided by negative 1. And just rewriting this nicely, it's going to be minus 1 over 1 plus ln x. Okay, great. So now we can go ahead and apply our, oh, that's v. Now we can go ahead and apply our integration by parts formula. So we have I equals u times v, so it's going to be minus x log x on 1 plus log x, and then it's going to be minus the integral of u dash times v. So it's going to be another minus here, so it's going to be 1 plus log x over log x, 1 plus log x, and dx. Of course, this can be simplified quite easily. To be the integral of 1, which we know is x, and of course we can't forget our constant. Now we can simplify this a little bit more. If we make a common denominator between these two, we're going to get minus x log x, what's wrong with my logs, log x, plus x times 1 plus log x, plus c, but this is all over 1 plus log x. So we're going to get minus x log x plus x log x all over 1 plus log x plus c. We can see these will cancel, and we're left with x over 1 plus log x plus c. And that is your final answer.